Addition and subtraction of fractions, Lesson 1.
7.3b Computations and Algebraic Relationships. Apply and extend previous understandings of operations to solve problems using addition, subtraction, multiplication, and division of rational numbers, specifically fractions. This is a readiness standard in reporting category 2. Today is your day. Welcome to class. To be successful today, we will need a computer, a notebook, pen, pencils, color pencils, and markers. Today we are going to complete the Do Now, learn and practice how to add and subtract fractions, and complete the exit ticket. Please remember, kindness is free, so give it away. To begin the Do Now, we are going to write out our multiplication facts from 1 to 12. There is an embedded YouTube timer for 10 minutes that you are allowed to use if you choose. Please try your best to complete this multiplication table in under 10 minutes. There is a blank multiplication chart available to you in PDF form if you would like to print that down and use that for a template. Adding fractions with like denominators. To add fractions with like denominators, where we have a numerator over a denominator plus a numerator over the same denominator, we add the numerators and keep the denominator. In these two examples below, we can see that the numerator is on top, and those are represented by numbers 1 and 3. The denominators are on the bottom, and these are the same. They are both 4. Adding fractions with like denominators. The purpose of the denominator is to tell you how many parts you need to make a whole. So in this situation, we have 2 parts in order to make a whole for this fraction, and 2 parts to make a whole for this fraction. That means that when we draw a model, we are going to separate that single model into 2 parts. The numerator tells us how many parts that we have. Because the numerator here says 1, we only highlight 1 of those pieces. Here, the numerator says that we have 3 parts, so we highlight 3 of those pieces. Now you can see in this example, using the models, that there are 4 total parts out of the 2 that we need. So we would write this as 4 over 2. There are 4 parts that we need out of the 2 that are required to make a whole. Now we can also see that 2 wholes have been developed. This is 1 whole. This is 1 whole. So 4 halves is also the same as 2 wholes. Let's try that on the number line. We know that 2 individual sections will make up 1 whole. So here we have 1 section, 2 section, that will give us 1 whole. Here again, 2 more sections make up another whole, which would be 2 wholes. And 2 more sections make up another whole, which would be 3 wholes. Now, as we began, we started with 1 out of 2 sections, and then we added to that 1, 2, 3 out of 2 sections. So once we combine those together, we see that that gives us the same answer we came up with before. We can either call that 4 over 2, which we usually don't do. We usually simplify that down to 2 wholes. Here is a video that you can watch for additional resource and additional practice. Let's check your understanding. To solve this problem, you will need to draw several pieces that consist of 9 parts and a number line that consists of 9 parts. You will also need a second problem set up for a section that consists of 5 parts, and then a number line that has 5 parts as well. So please remember, the denominator tells us how many parts are in the entirety of the shape or the whole. So here we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 parts in this whole shape. Now what we're going to do here is we're going to shade in 8 of those parts. So that is 1, 2, 3, 4, 5, 6, 7, 8 out of the 9 that we need. Here in the second problem, we can add 4 more parts to that. So here I'm going to shade in the other direction 1, but now you can see that we're overlapping into the second hole. Well, that's okay. We can just continue going on. So 1, 2, 3, 4. And we see here that we have a total of 1 whole and 1/3. The reason why we call that 1/3 is we can separate that out into 3 sections. So we get 1 out of the 3 sections for each of those. 1 and 1/3. If we wanted to name this as an improper fraction, we can just name the number of parts that we have, which would be 12 total parts out of the 9 that we need to make a whole. This one is called an improper fraction. When we write our answers, we usually like to show them as mixed fractions, especially if they have whole components as well as fractional components. Now let's show this information on the number line. On our number line, we know that each whole is separated into 9 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9 makes 1 whole. 1, 2, 3, 4, 5, 6, 7, 8, 9 makes a second whole, and we can continue on. So we're going to start with our first fraction, and we're going to use 8 of those pieces. 1, 2, 3, 4, 5, 6, 7, 8. And to that, we're going to add 4 additional pieces. 1, 2, 3, 4. That gives us a stopping point of approximately here, which if we cut those in that second hole, if we cut it up, we can see that we only have 1/3 out of the 3 that we would need to fill in the entire section. So here again, this is 1 and 1/3. All right, you are more than welcome to hit pause on the video and try the second problem for yourself. If not, let's continue. How many parts should we have here according to the denominator? That answer is 5. And we can see here we have 1, 2, 3, 4, 5 parts in each of the sections. Now we're going to add 2 parts out of 5 to 3 parts out of 5. Now what happened there? We can see that we filled the entire thing up, and that gave us an answer of 1 whole. So if we wanted to look at only the parts that were available to us versus the parts that we needed, we can write an improper fraction, or in this case, a proper fraction, 5/5. We always remember to simplify those fractions, however. So that's why we use the whole number 1 whole. Now to show this on the number line, it is the same process. We want to make sure that the denominator tells us how many sections we need. And in this case, it is 5, 1, 2, 3, 4, 5 sections before we make a full whole. So we're going to add 2 of those sections from that first fraction to 3 sections from the second fraction, and we can see there again it stops at 1 whole, which is the same as the 5 pieces we have out of the 5 pieces that we need. Here's another video for you to continue to review adding proper fractions with like denominators and reducing it to their lowest term. What if we wanted to add fractions with unlike denominators? Now we first need to notice where the denominator is. The denominator is on the bottom of our fraction. And here you can see this denominator is 3. and this denominator is 13. That means those fractions are different. This here is sectioned into 3 parts, while this denominator is sectioned into 13 parts. There are many more parts to work with when the denominator is larger. If the denominators are not the same, you must find the common denominator by finding the least common multiple. So let's practice that. Adding fractions with unlike denominators. As we can see here, we have 2 denominators. One of the denominators is 3. That means we're dividing our whole into 3 pieces. The second denominator here is 2. That means we're dividing our whole into 2 pieces. So the first thing that we would like to do is to find a multiple that they have in common. And the way that we begin that is we begin writing out all of our multiples, starting with the first denominator. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. The next is for the second fraction, we would like to multiply by 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. Now what we're looking for is the least common multiple. So what number do both of these fractions multiply to and have that are the same? So as we're looking here, the lowest number that they have in common is 6. Both of them share a multiple of 6. So now we need to figure out how can we make both of our numbers turn into 6. Well, that is very simple. We write our fraction, 1/3, and we want to convert that one to 6. Well, how did we get to 6? We multiplied by 2. So here we write times 2. For the second fraction, which was 3/2, what did we do to get 6? Well, we multiplied that 2 by 3. So that's what we're going to write here. So now we know that we show arrows to show multiplication. So let's do just that. 1 times 2 is 2. 3 times 2 is 6. 3 times 3 is 9. 2 times 3 is 6. So now we can see we have 2 fractions here that have the exact same denominator. So we have converted those two to 6 plus 9/6. And how do we add fractions that have like denominators? We simply add the numerators. So our in-between or intermediate step would be 2 plus 9 over 6. 2 plus 9 is 11 over 6. We just bring that denominator right on over. Now, one thing we need to do is we need to make sure that we simplify, and an easy way to show that is putting it on a model. So here we need 6 pieces for each of our wholes. And out of the 6 needed for each one, we are going to add 11 pieces in to see how many wholes that we can get. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, here we can see that this is one whole. And here we only have 5 out of the 6 pieces remaining. So 11 over 6 can be written as an improper fraction, or it can be converted to a mixed fraction, giving us a value of 1 and 5/6. And that is called a mixed fraction. Perfect. I would like for you to try this check for understanding for adding proper fractions with unlike denominators. Awesome. Let's begin. So here we can see that we have a denominator of 9 and a denominator of 6. The first thing that we would like to do is to multiply or to find all of the multiples for each of these. So we're going to times 1 first, 9 and 6. There's no matches there, so we can continue. Times 2, we have 18. 6 times 2 is 12. So we still don't have any matches there. Let's continue. Times 3. 9 times 3 is 27. 6 times 3 is 18. And there we have a match. The multiple that is the same here would be 18, and that's the smallest one, so that is called the least common multiple. Now remember, the way that we convert these is we write our fractions. And we show with arrows what we did to get there. So how do we change that 9 to an 18? We multiply by 2 times 2. How do we change that 6 to an 18? We multiply by 3 times 3. So now we show our multiplication with arrows. 8 times 2 is 16. 9 times 2 is 18. 4 times 3 is 12. 6 times 3 is 18. So now that our denominators are the same, we add 16 over 18 plus 12 over 18. That gives us an in-between step or an intermediate step of 16 plus 12 over 18, which we know to be 28 over 18. All right. So now I know that a whole piece includes 18 parts from it, so I can take this 28 over 18 and I can subtract a whole from that. Take 18 parts out. That way I know that there will be one whole and 10 over 18 left. Now we can simplify that down to give us a value of 1 and 5/9. Please review all resources if you do not understand how to simplify, or send me a message and we can discuss it. I want you to hit the pause button and I want you to try the second check for understanding and then come on back. All right, welcome back. Let's continue our check for understanding here. We're looking at denominators 4 and 5. So those are unlike denominators. They are different from one another. So that means we need to write out the multiplication facts for these. First one times 1. 4 times 1 is 4. 5 times 1 is 5. Those are not the same. Times 2. 4 times 2 is 8. 5 times 2 is 10. I still don't have any matches, so let's continue. Times 3. 4 times 3 is 12. 5 times 3 is 15. Times 4. 4 times 4 is 16. 4 times 5 is 20. Still no matches there. Times 5. 4 times 5 is 20. And 5 times 5 is 25. So I can see a match here. And this is the smallest match that we have. 20, that means our LCM is 20. The multiple that they have in common, that is the lowest, is 20. So we rewrite our fractions, 2 over 4 and 3 over 5. And then we decide what we had to do to get there. So to change the 4 to 20, I had to multiply by 5. To change the 5 to 20, I had to multiply by 4. So now I show my multiplication with arrows. 2 times 5 is 10. 4 times 5 is 20. We have 10 over 20 there. Next, 3 times 4 is 12. 5 times 4 is 20. Now I can see that my denominators are the same. That gives me 10 over 20 plus 12 over 20. 10 over 20 and 12 over 20 give us an intermediate step of 10 plus 12 over 20, which we can work down to get a value of 22 over 20. Now I know from one whole I can subtract 20 pieces to give me one whole, so therefore I will have one whole and 2 out of the 20 pieces left over. From there, I continue to simplify, and my answer is 1 and 1/10. Please remember to send me any messages if you have any questions or concerns of how I simplified there. Next step is subtracting fractions. Nearly the exact same rules apply as adding fractions. We have to decide, do we have a common denominator or do we have an uncommon denominator? One thing I need for you to remember, a whole number minus a fraction, we can always change that whole number into a fraction by simply placing that whole number over 1. So 4 would change into 4 over 1. 6 would change into 6 over 1. 19 would convert to 19 over 1. So remember, you can always change your whole number to a fraction, and you can change your whole number to a fraction by writing that whole number over 1. Please review the video below if you need additional support in this area. Let's begin by subtracting fractions that have a like denominator. Here, our denominator is 2. That means the number of parts that are needed to make a whole are 2 parts for each of the sections. We can also see that we start with 3 parts. 1, 2, 3, and then we subtract 1 of those 2 parts. That leaves us only with 1 whole, or 2 parts out of 2. Let's try one with unlike denominators. We can see here we have a denominator of 5 and we have a denominator of 4. Those denominators are different. They are called unlike denominators. So the first thing we need to do is show the multiplication of these. So we have times 1, 5, and 4. Times 2, 10, 8. Times 3, 15, 12. Times 4, 20, 16. Times 5, 25, and 20. And here again we have a match of 20. So the least common multiple that 5 and 4 share is 20. Now we're going to convert those fractions, 3/5 and 2/4. What did we need to do to get there? So for the denominator that started with 5, we needed to multiply by 4. So we write times 4. For the denominator that was 4, we needed to multiply by 5. So we write times 5. And we simply show our multiplication with arrows. 3 times 4 is 12. 5 times 4 is 20. 2 times 5 is 10. 4 times 5 is 20. So what we have here is 12 plus 10 over 20, which gives us a value of 22 over 20. And we have seen this before. We can subtract that 20 to give us 1 whole and 2 over 20 that we simplify down to 1 and 1/10. All right. If you want to try that using the models, please feel free, and I would be more than happy if you shared that with me. You can share that with me on a message via picture, image, video recording, or you can just send me a text explanation of what you chose to do. What if we are working with a problem in which we do not have a fraction? Well, the answer is to change it to a fraction. Please remember, 3 can always be changed to 3 over 1. Perfect. Looking at the denominators here, we have 1 as a denominator and 5 as a denominator. Those are not the same, so we need to write out our multiplication facts for these. We have times 1 is 1, times 2 is 2, times 3 is 3, times 4 is 4, times 5 is 5. Here we have 5, 10, 15, 20, and 25. The number that they have in common is 5, very simply. So their least common multiple is 5. We're going to go back and rewrite our fractions. 3 over 1. And what did we need to do to get there? We needed to multiply by 5, so I will put times 5. Then we have 4 over 5. And what did we need to get to get there? Multiply by 1. So that leaves us with multiplication here. 3 times 5 is 15. 1 times 5 is 5. 4 times 1 is 4. 5 times 1 is 5. That gives us 15 minus 4 over 5, which is the same as 11 over 5. Now this one again, we can easily model, because how many parts should be in each of these boxes? Absolutely right. There should be a total of 5 parts. So you can show it in 5 sections this way, or you can show it in 5 sections this way. I would love for you to share your understanding with me, just to make sure that we are on the same page there and that you know how to show it using models. Now I'm going to back up to this problem here because I solved this problem as if it were an addition problem, and it is not. So let's go back and fix this problem. This is not an addition problem. All right. So here we should have 12 over 20 minus 10 over 20. 12 minus 10 would be our intermediate step over 20. 12 minus 10 is 2 over 20, and we can simplify that down to 1 over 10. Now please, just as I was saying before, go back and share with me how we worked this problem out using models. I would love to hear from you. My apologies for doing that wrong, but that's what happens with math. Sometimes you need to go back and check and make sure you are doing the problems properly. Let's continue. What is a mixed number? Well, as we shared before, a mixed number is a whole number and a fraction. The operation between the two is addition. So for example, I have 4 and 1/2. That means I have 4 whole pieces plus another piece that is 1 out of the 2 needed to make a whole. Here I have 6 and 3/4. So we use the word and. If we wanted to convert a mixed number to an improper fraction, we can use something that we lovingly call the Texas turnstile. That means we would multiply the denominator and the whole number. Okay, that would tell us how many pieces we need in 5 complete units if there were 3 needed for each whole. So 3 times 5 would be step number 1 here. The next thing we do is we add to that answer whatever our numerator is. We add to that answer our numerator. So here that would be plus 2. Now the answer we get from there goes into the numerator position. 3 times 5 is 15. 15 plus 2 is 17. So we take 17 and we place it right here in the numerator position. We keep the denominator exactly the same. So we just scooch that right on over. The denominator is exactly the same. Now there are different ways that we can add and subtract mixed numbers. We can add them by separating the whole number from the fraction, or we can stack them on top of each other in a second form. Please check out the videos to see which one you would prefer to do best. Let's add and subtract mixed fractions. So here, I'm going to be adding these 2 fractions here, 5 and 1/3 and 6 and 2/5. So what I like to do is I like to separate my whole numbers from my fractions. So my whole numbers first, let's put those here. 5 plus 6. That gives me a value of 11. And then I like to work with my fractions. 1/3 plus 2/5. Now here we can see that our denominators are not the same. So we have to do what we can to make them the same, and that's using least common multiple. So I'm going to write my multiples of 3, 6, 9, 12, 15, and that would be times 1, times 2, times 3, times 4, and times 5. And then I'm going to write my multiples for 5. 5, 10, 15, 20, 25. Now what multiple do they have in common? That answer is 15, and that is the smallest multiple that they have in common. So to convert that, I'm going to take this entire section here and I'm going to multiply it by 5. The reason why I'm going to multiply it by 5 is I need that denominator of 3 to be multiplied by 5 to change into 15. So 1 times 5 is 5. 3 times 5 is 15. And to that, I'm going to add my second fraction, which is the 2/5. So how do I convert that 2/5? I need to multiply that one by 3. So that means I'm going to take this entire fraction here and I'm going to multiply it by 3. So here I have 2 times 3, which is 6, and 5 times 3, which is 15. That's going to bring me down to my in-between step, 5 plus 6 over 15, which is 11 over 15. Now I have to remember that I have my whole number portion and my fraction portion that I need to put back together using addition. So the answer to this problem would be 11 and 11 over 15. Right? Let's try one more, and this time let's subtract them. So I like working with my whole numbers first, 16 and 4. And I'm just going to make a note here. 16 minus 4. 16 minus 4 is 12. Then I'm going to use my fractions, 3/4 and 2/4, and I'm going to subtract those away from each other. Because the denominator is the same for these fractions, I know that I just combine the numerators. Now the trick here is you cannot switch the numerators places. So if the 3 comes first and the 2 is second, that is exactly how we have to leave it. That is so important when we're subtracting. Now when we're adding, they can trade places, but when we're subtracting, they cannot. So here we have 3 minus 2 over 4, which we know simplifies down to 1 over 4. Now remember, we have our whole number portion and we have our fraction portion, so we have to put those together in order to make our answer 12 and 1/4. Perfect, perfect, perfect. Now let's wrap up for this lesson. Here we go. This week, Matthew will practice with his band for 1 1/2 hours on Monday, for 1 3/4 hours on Tuesday, and for 2 hours on Wednesday. Next week, Matthew will practice with his band for the same number of hours on Monday, Tuesday, and Wednesday. What is the total number of hours Matthew will practice with his band over these 6 days? So we want to know what is happening during that first week on Monday, Tuesday, and Wednesday. And in order for us to get this total, we want to add these numbers together. So that is 1 1/2 for Monday, plus 1 3/4 for Tuesday, plus 2 for Wednesday. So because we are adding these mixed fractions, I like to separate my whole numbers and my fractions. So that gives me one whole number, one whole number, one whole number. And that is 1 plus 1 plus 2, which we know is 4. That is our whole number. Now we have to add the fractions. So we have 1/2 plus 3/4. And we can see that those denominators are not the same, so we have to make them the same. So we're going to write our multiplication tables here. Times 1, times 2, times 3. And I believe we only need to go to 3. If we don't find a match, we can move further. So 2 times 1 is 2. 2 times 2 is 4. 2 times 4 is 6. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So as we can see here, we have a match there with those 4s. So that means we can convert both of those to have a denominator of 4. So let's change that. Denominator of 4, denominator of 4. That is my goal. So how do I change that 2 to a 4? Well, I multiply it by 2. So I take this entire fraction here and I multiply it by 2. 1 times 2 is 2. 2 times 2 is 4. How do I change this second fraction? Well, this is times 1, so I don't need to change the fraction at all. I just take this entire thing and multiply it here times 1, which is the same as 3/4. So from that, now I have denominators that are the same. I have 2/4 plus 3/4, which gives me a total of 5/4. Now, if I were to draw a model, I know that I need 4 pieces in there to make it whole, but I actually have 5 pieces. So that means 1, 2, 3, 4, 5. That means I filled up one hole completely, and then 1 out of 4 pieces remain. So I take that one hole and I have to make sure that I come back and add that to the one hole that's here. So that additional one hole gives me 5 holes, and what is remaining? Plus that 1/4. So in 1 week, Monday, Tuesday, and Wednesday, Matthew is going to study with his band 5 1/4 hours. If we wanted to add week 2 to that, we can just add it together, 5 1/4 hours here again for week 2. Now we can add this hole and this hole to give us 5 plus 5, which is 10. Then we can add this fraction and this fraction, 1/4 plus 1/4, which gives us a value of 2/4. Now remember, we can simplify that down, 1/2. So our answer would be 10 1/2 for 2 weeks of activity. All right. Discussion, questions, and activity time. Question: is it easier to add and subtract fractions with unlike denominators, or is it easier to add and subtract fractions with mixed fractions? I want you to go to the Google form and submit your answer. Please remember that if you would like a response from me, that you need to ensure that your name is at the very last of the form.